Thanks, Pavel. We'll give another minute or so, make sure everybody logs on. Time is counting down, eh? Another month and a half and you're done. Yeah, that happens sometimes. I know yesterday they had a big problem with Learn and our WebEx between Microsoft and the college. So there was a time where you couldn't get onto Learn. Yeah, another month and a half, and then you guys are done, eh? You start your careers. Gonna go out and make the big bucks, right? Yeah. When do you guys make your presentations for your ARP? Is that middle of April sometime? You guys can open your mic up if you want.
Hi, John. Yeah, I think April 16th, I think.
April 16th. So you guys are all going to be ready?
Sorry, 14th.
14th.
Trying.
You're trying. So you still have a lot of, you guys have a lot of work yet or almost complete?
I think it's mostly editing the draft and yeah, a little bit more to do. Just like finishing it off. Not
Okay,
sure
so
about the other groups.
Yeah. So you're going to present online, I guess, to the instructors? Is that how it works?
Yeah, I think so. I think next week they're going to talk a bit more about it.
Okay. Okay. Good. Yeah, because I know in the past they used to have it in the lecture theaters and down by the South Gym, and the instructors and guests, and even second-year students would come and witness the presentation, so they have an idea as to what they're going to be up against in their next year, sort of thing. So it's always a good thing to see it in person because you're on stage, you're using your overheads, almost like if you would be making a presentation in industry to a client or whatever the case may be.
Yeah, I saw some in first year on steel fibers and concrete. It was really quite interesting to see
Oh, yeah.
also.
Yeah. Yeah. Oh, okay. So you were in first year and you went. Oh, nice.
I think they invited all of us, and most of our schedule, I think, might have conflicted with some of it, but yeah, it was really good to watch.
Yeah, it is because it gives you kind of an idea of what you have to prepare for. We've always had some discussions with students that they actually would like to start an ARP project in second year because it is a big job. I mean, as soon as you come back in October, you within a week or two, you got to start planning your ARP because it's a long drawn out presentation or project. So second year would be good, but sometimes between second and third year, people change or they move on or they don't come back, but it can be done.
Yeah, that makes sense.
Yeah, because usually in second year and you're moving into third year together, the same group, especially in the municipal and even structural. So, but that's interesting. Good. Maybe I'll catch a few of the presentations. I used to sit on a lot of the marking or putting in my 2 cents worth for what it's worth. Okay.
Last year they didn't present, right?
Not in person, no. It went quickly, I believe, online because, it's a year ago now, March 12th, was it, that we actually had to shut the college down. And again, even last year, the presentations are usually mid-April. And then you have a week or two to get your final report in after that. Because usually when you make your in-person presentations, you still have time to edit and, clean up your written part, the submission part.
Yeah, I was told by some of them last year that they didn't present. They literally just handed in their report
Mm-hmm.
because of COVID.
Yeah, yeah, that happened, but I thought there was a couple, maybe not. But and then I know they really started looking at it this year as to how they're going to do it. So it'll be interesting. Anyways, good luck, you guys. See, I was quite fortunate when I went through this course. We didn't have to do that. We just did our 2 years, and you have to have over 50% to pass, and away you went. Oh well. That doesn't necessarily mean it was better. It was less work, I think. Well, no, we had a full schedule. I actually found my schedule yet from some 48 years ago. I was cleaning out my workshop and all my old files, and I found my old registration. I think my course was tuition, I think was $400. My textbooks amounted to a total of less than 100, I think. So it's quite funny. I actually found that and sent it off to Sherry, put into the archives. Just to show you about inflation, I guess. Anyhow, okay. Might as well get started here. I'm going to put the recording on. Just give me a minute here. Okay, we're up and running. So, everybody's doing okay? Everybody had a good weekend? Let me know if my audio isn't working from time to time. It goes out sometimes, I think. So just tough time hearing me.
I think there's an issue with putting in the chat to everyone. So I think you're going to be getting a lot of private messages if you ask questions.
Oh, I see. Okay. Yeah, it's good. I can see it. I'll keep the chats open and see things. Okay, we've got 2 more units. There's no lab today, so we'll just carry on. And hopefully I'll cover the last 9 and 10 units on joints and curing concrete. We only covered 1 unit last week. We can still make up that other unit if you want today. We can take a little break and maybe do it in the afternoon or whatever, or just continue right straight through. And we can pick up that unit that we mixed yesterday, that we missed last week on the actual placing and finishing. Again, in the uploaded learn, I highlighted the key points, so we can leave it at that if you want. And if you have any questions, definitely get back at me. These next 2 units are going to clean up, I guess, the concrete portion for this year, and then we're going to start on asphalt. And I'm going to just finalize all the notes on that because I'm doing some reduction. Because asphalt is actually a fairly extensive coverage. When it comes to mixed designs, we're going to really cut that down. I've got Ray, who's our lab assistant, while Jody's on maternity leave. We got him from industry. He's putting together a little bit of a video on compacting Marshall briquettes, asphalt. I found numerous ones online, but they're not always that good. I haven't found a guru like Tyler Lay in concrete. I haven't found one for asphalt that I'm happy with yet, but not to say that it's not out there. I just haven't come across. Yeah, that's a good one, Pavel. Yeah, it's asphalt. Okay, not asphalt. And I got to really stop and catch myself. I do say asphalt many times because that's the way we talked about it. But it's not ash. It's asphalt. ASPH, which sounds like an F. So asphalt is the proper pronunciation. It's the same thing, Pavel. When I hear people say I got a cement driveway. No, you don't. You've got a concrete driveway. Cement is the powder or the flour, if you want to call it, that binds the aggregates together. But you even hear on the news with the reporters, they'll talk about a cement truck got caught in a pothole or something like that. So anyhow, asphalt, okay. So anyways, we're going to finish off the units for concrete. And the last two, I've tried to set it up sort of in order, as you may have noticed. Okay, now we've placed concrete, we've batched it, we placed it, we finished it. Some of you that have been involved in concrete, after you place the concrete, what do you do? Okay, you've screeded it. Okay, you've gone over it with a screed. You might have used say if it's a pavement, you might have used a highway straight edge. You flattened out the concrete, you remove the high spots with the big highway straight edge, the big 10-foot screed that they manually screed across. Joint cuts, right, Clive? Why do we have to cut concrete? Who cares? Why cut it?
To allow for movement.
You're right. Control cracking, right, Sean and Fabian, and I missed who mentioned it. Was that you, Kelly?
Yes.
Yeah, good. Yeah, I sometimes see you guys flash up here on my screen, but I miss it sometimes. Yeah, we have to tell it where we want it to crack, because concrete's going to crack. Anything that shrinks or anything that dries, I should say, and concrete's one of them, has volume change. And concrete is very, very, very weak in tension. It's great in compression, but from a tension point of view, it's very brittle. It doesn't bend very much before it cracks. So concrete, I mean, you put a cake batter in the oven, okay, when you pull it out after it bakes, it shrinks, right? And many times your cake might crack across, and sometimes you get upset because if you want to put icing on it or whatever. But there's a volume change, okay? It's shrinking. And it's going to crack. It's got to, because of the restrained movements. So if we weaken it by cutting it, we'll say, okay, I've weakened this place here, you crack here. You move over 3 meters or 4 meters, depending on the width of the pavement and the length, and you cut it again, and you cut it again. So if you've ever looked at the way these joints work, I remember with Highway 75, we placed about, steel bars are good in tension. They may be temperature cracking, but that's about all. Temperature steel. Reinforcing and pavements give you nothing as far as strength. Okay? Your concrete will crack. It's going to want to pull apart because of movement and frost action. So you'll put in dowels, or you may put in reinforcing rebar to just kind of hold it in. But it doesn't make the concrete any stronger. You're landing 747 cargo jumbos on the airport in Winnipeg here on concrete pavements. There's not an ounce of reinforcement in there. Our pavements, we don't put reinforcing in only on the control joints, okay, for load transfer. But in between the control joints, there's no reinforcing, okay? You can put reinforcing sometimes that'll stop temperature cracking, but it only pulls it together, ties it together, in other words, okay? Because if your concrete's going to crack, you're going to get water freezing in the crack, and it's going to pull apart. Plus the concrete itself is going to undergo temperature movement. You don't need it. Why do you put steel on at 16 inches on center in a garage slab? I have a question. No problem. You don't need it. Your garage floor might crack. You could have water. If it's not a heated garage, let's say it goes under temperature change. So you get water dripping off your car, whatever the case may be. It gets into the crack. It freezes. It expands. It's going to pull your slabs apart, okay? So you got reinforcing in there tonight. But that reinforcing does not give you any additional strength to the concrete. And why is that? So why does the engineer want it in the plans? Some of them don't understand it. Where does the reinforcing go in your garage slab? Anybody? Is it at the bottom of the slab? Is it near the top of the slab? Where does it go?
Is it not in the middle?
It's in the middle. Clive, you said lower third. It might be in the lower third if they don't pick it up. Sometimes the guys put reinforcing in, and you can see that if they don't, they'll back in a truck sometimes right onto the driveway, especially if they can't pour from the side. So they'll leave the mats of steel on the ground. They'll place the concrete, and then as they move forward with the concrete, they lift the steel and put chairs underneath it. But if it's in the middle, go back to your statics and strength of material. okay, still cancels out. It's in the middle. It gives you no strap. Now, a structural slab, if you had a structural slab where you had top steel and bottom steel, yes, that's different. It's now the steel that is giving you the load carrying capabilities. You got to have reinforcing in it. But if it's in the middle, you actually, what's that, axial symmetry is 0. If you put it in the bottom, yeah, but they don't. I mean, yeah, you can put your reinforcing because that's where the tension is. You're right. It's in the bottom. Upper part's compression, but they don't. They'll put it in the middle. I think a lot of it is just the fact that it's a comfort level, or maybe not understand. Now, it does control something to do with temperature, okay? Temperature steel, as they call it. But from a structural point of view, our pavements don't have it. You ask the engineer who's doing your garage floor, or your warehouse floor, or whatever, why are they putting in reinforcing? And why isn't there any in the airport? I don't think airports even put in any dowel assemblies for load transfer. And we're going to get into that. How the load goes from one side. Because when you're driving down the highway, okay, let's say you got an 18-wheeler, you got a semi-loaded. You're going over one slab. When you enter a new slab, you know, on the other side of the transverse control joint, that slab's going into settlement, okay? You're loading it. You're going to have settlement. As you're coming off the other one, it's going in rebound, okay? So you got to transfer the load from one slab to the other slab. So you're going to get movement, okay? As he carries on, you're going to leave that slab, the next slab, it goes back up to rebound. So you load it, get off it, it comes back up. So you need load transfer over that joint. And one way of doing it is putting dowel assemblies or dowels. We call them assemblies because they're usually come in a mat. You pin them down, they sit in their own chairs, slip-form paver comes over it. Okay? And yeah, so we're going to get into this. We'll talk into joints and then we'll get into curing because after you cut it, you'll be curing it. Now, chances are you should be curing it even before you're cutting it. In the warm climate, is that the same where there's less range of temperature? True, Clive. I think Texas is the only state that I heard when I was at that conference in San Antonio that does totally reinforce or continuously reinforced concrete pavements. Okay, they put mats the whole through. Whereas the other ones just basically go to jointed plane. Like our pavements are called jointed plane pavements. They're jointed, okay, with the saw cuts. But they're not reinforced because there's no reinforcing between the control joints. We have dowels, yes, but that's to transfer the load. And you may have seen in some states and even here on the Highway 75, where the old sections were designed with no transfer dowels across the joint. So what they actually do in the States and what they've done here is they'll go in with a contractor and he cuts slots right across those joints. The little dados, if you want to call them, if you do woodworking, okay? And they'll drop a rebar in it, grout it in, so you'll have your 6 or 8 dowels across the width of your pavement. Then they move to the next control joint. They'll cut slots right through it, like little troughs, and they'll drop a dowel in it, grout it in, move on to the next one. So they're rehabilitating the pavements. What we used to rely on to transfer the load, if you don't have a dowel, how does that load get transferred? How do you keep the pavements together? Anybody? Okay, we can put dowel assemblies or dowels, reinforcing steel, across the joint. But if we don't have joints like at the airport, how do they rely on one slab transferring the load to the other slab? Anybody? If you cut that concrete, do you cut it full depth? Anybody? No, you don't. 1/3 D or 1/4 D. Okay, quarter of the slab thickness or a third. You've weakened it at the top now, right? So the concrete, as it's starting to shrink or move, typically when you pour a new slab, is going to want to shrink because it's setting up. Okay, it's hardening, it's changing volume. The weakest link of that concrete thickness is where you cut it. So it's going to crack underneath it. And if you ever watch pavement, excuse me, walk along the side of the pavement before they backfill the sides, and you'll see that underneath each saw cut, there will be a crack, or there may be a crack coming. When we did Highway 75, we'd pour about 1 kilometer one day. The next day I would walk what we did the previous day. And I would see that after the contractor cut, every seventh joint would crack. Then the next day, so in other words, 2 days after we placed it, I'd walk it again and I'd see that now maybe every third joint is cracked. And then the third day, I'd walk it again and the other joints that haven't cracked would start to crack. Okay, so as the concrete is setting or hardening, say 3 days, 4 days, it's still undergoing a volume change and it's cracking, okay? So it doesn't all crack at once. It's based on the length and based on the spacing. There's a certain spacing, and we'll look at that right away. Anyhow, we're gonna get into that, and maybe it all makes sense, but you wanna provide a weak link. You crack here. All it does is that it gives us a systematic aesthetic look instead of having concrete crack all over the place. And you'll see a lot of pavements around or a lot of concrete slabs, driveways that may have never been cut. So they're gonna crack where they're gonna want to cut, okay? Where there's more restraint. We also have a term that's referred to as subgrade drag. You place your concrete on a pavement. Sorry, you put your pavement on a granular base, okay? You're paving. There's friction between the bottom of the pavement and your base. Okay, your concrete now wants to shrink, right? Because it's hardening up. But there's friction between the base and the bottom part of your slab, and it holds it. So you're restraining it. It's going to crack. One wants to move. One tells you, no, I'm not going to let you move. It's got to give somewhere. It's got to give somewhere. Okay? Any questions so far? Okay. Let's go see what here. I'm going to do a little bit of sharing here. See what we've got. Put my screen here. I'm looking sideways now because I'm using my big monitor here, so I'm not looking directly at you, but I can still see you both. Okay, let's go to share. And we're going to switch. Okay, everybody see that okay? Chat out. You can see it now? Good, okay. Joints, pavement joints. When I first set up the meeting, I just said joints. And then I figured, bad term for joints. Better put concrete in there, or pavement. Okay. Anyhow. So we placed the concrete, we finished it, and we're gonna cut it. Install control joints, pavement joints. Typically, it's gonna take a little bit of time from when you place that concrete to when you cut it. But also, the next unit, we're gonna cover curing. You should start curing immediately when you can. Because as soon as you place that concrete, it's starting to harden, right? Remember, hydration's taking place as soon as moisture and cement comes together. You'll see many times, and I've noticed this last year and the year before, we did some sidewalk repairs here in our small community of St. Adolphe. And I saw the contractor placing concrete sidewalks. And some of them would be, maybe 100 feet in length, 30 meters, and then he'd jump and go to the other part of the sidewalk that needed, because they didn't replace all the sidewalks, they just repaired the ones that were badly deteriorated. But he had long sections of pavement, sidewalk pavement, if you want to call it. And he didn't cure till the end of the day. That's a no-no. You got to cure as soon as possible after you're finished. It's starting to shrink. You want that moisture, and it was a hot day. You're getting a lot of moisture loss out of your pavement due to evaporation, whereas you want it in the pavement, in the concrete, to hydrate, to react with the cement and create strength. Okay. So if you ever see that, they should be erect soon, but small town, the superintendent here, I didn't even see him around half the time, so who knows. Anyways, Control joints for concrete slabs. Very important. Concrete expands and contracts with changes in moisture and temperature. We know that. And we'll look how temperature influences the strength development. Ambient temperature is going to also influence your concrete temperature. Wind speed is going to play havoc on your concrete. Humidity. Here's a good point, guys. You're watching a paving crew place concrete, okay? Say it's about 32 summer day. Maybe they shouldn't be placing it, but they're placing it, okay? So I'm going to give you two scenarios. One scenario is you see the guys placing concrete or finishing, and they're just sweating, okay? They're perspiring. You can just see them dripping wet, their hair's wet, coming from below their hard hats, okay? Then the next scenario is they're placing concrete again, hot out, but they're not sweating. But they're working hard. They're finishing, they're darbying, they're bull floating, okay? Then they do maybe trowel finish, maybe not, but they're not sweating. Under those two scenarios, which crew should have been placing concrete, which one shouldn't maybe? Anybody? Okay. Oh, okay. The one sweating shouldn't be placing? Who agrees with that? If you're sweating, okay, the moisture's dripping off you. Is your relative humidity in the ambient temperature or relative humidity, is it high or low if you're sweating? What happens when you step out of, okay, high. Right. What happens when you step out of the shower into your washroom? When you step out of the tub, out of the shower, you step out to dry yourself. What usually happens? You shiver a little bit, right? If you got the exhaust fan running in your bathroom, humidity from your shower is being sucked out. If humidity is low, you step out. The water now starts to evaporate off your body, gives you a cooling effect. So those guys that are sweating, the relative humidity is high. That means there's a lot of moisture in the atmosphere. Perfect for concrete. The water from the concrete's got no place to evaporate. I mean, there's always some evaporation, but if you have a high relative humidity, your moisture in the atmosphere, in the ambient condition, is there. It's not going to draw water to your pavement. But if your relative humidity is dry, your concrete's wet, it's going to draw the moisture out. So when you ever want a paving job, if you see those guys sweating, you say, oh, that's a good thing. But if they're working equally as hard and there's no sweating going on, they're not perspiring, that means they may start to perspire, but it evaporates, you don't see it. Okay? So you want the relative humidity high in the atmosphere. And you'll see many times on a big paving job, or even in the States, they'll have atomizers. They have big fogging hoses where they'll shoot moisture into the air, not onto the pavement, because it'll disrupt it. Okay? They'll shoot it into the air. They're fogging, they're misting. So they want moisture and they have to come down. You got to remember, concrete is denser than water. That's why you can pour concrete underwater without affecting the concrete. Okay, you can literally place concrete under the water and it'll push the water up without mixing into it, which is called trimming when you're doing deep foundations, caissons. Okay? So if they fog the atmosphere, they're getting the relative humidity into the air. That's going to prevent evaporation from the water from the concrete surface, okay? Because the concrete surface, if the moisture comes up and you're losing that moisture off the surface quicker, then you're going to get plastic shrinkage cracking. It's not structural, but they're fine cracking because the surface is starting to dry too quickly. So it's going to start developing little micro cracking called surface cracking. Okay. So anyways, concrete expands and contracts with changes in moisture and temperature. Unless these changes are controlled, they will cause cracks in concrete. And you can see here, okay, just a sketch. It's restrained the length, so it's going to want a volume change. So it's got to let go somewhere. Okay. To attain adequate workability, excessive water is used in concrete mixing, right? Okay, based on your last quiz, not too many people got that. They told me that it's great for hydration, but remember we talked about all you need is about a 0.25 to about 0.3 water cement ratio for hydration. The rest of the water is for workability. Some got that, some didn't. So that excess water is there to be able to place and finish it. Okay, so you're going to have excess water. And if it evaporates, some of it is obviously going to get hydrated with the cement. You're going to get volume change. You're going to get cracking. As a result, tensile stresses are induced into the pavement. The dimensional change of average concrete from the wet to dry states is approximately 17 millimeters for every 30 meters of length. Okay? 16 millimeters is about 5/8 of an inch if you're comfortable in imperial, but 30 meters is about 100 feet. So a little more than half an inch per 100, eh? That's a lot. That's a lot. Concrete, if restrained, will crack due to shrinkage, contraction, eh? On the other hand, concrete will buckle due to expansion. Have any of you guys ever, on a hot day, cloudy hot day is good then, right? Oh, sorry, Sasha. Well, not overly hot. Keep in mind that high temperatures also not very good in the fact that it's going to dry out, it's going to suck the water. But definitely cloudy, cool days is better. And if you have a cool day, you're not going to have a very high relative humidity usually, okay? But that's right, Sergeant. Cloudy the better. And less wind, no wind. Okay? So some of you may have been driving home from work or from college, and sometimes you'll see the curb just kind of buckled up. You'll see sidewalks or the sacrificial stripes along the median. They'll put the concrete pavement to prevent the grass, because usually the grass on the median or boulevard right next to the curb is shot because of the salt and sand that's thrown there from the de-icing days in winter, and vegetation doesn't want to grow there. So if you got a median, they'll put concrete almost like a sidewalk. It's not meant as a sidewalk on a median. Okay, that's to prevent the grass from dying from the salt that's thrown up too close. Okay, I call them sacrificial strips because you're sacrificing the concrete. But anyways, but sometimes you'll be driving home and you'll see those sidewalk even that people walk on. They'll have a couple of panels go up. You'll see sometimes the curb pushed up. That is due to expansion. And concrete will also expand on a hot day. If any of you guys are railroad people, anybody? You'll notice that a rail will stretch. Maintenance crew sometimes on a hot summer day, if it's 35 for any length of time, sometimes they'll go and they'll have to cut a piece of rail out because it stretches for the tracks, the trains. That's steel. Steel undergoes thermal movement. The longer it is, the more chance, okay? So we know that temperature plays havoc, thermal expansion, external and internal also. If concrete is restrained, it'll crack. On the other hand, concrete will buckle due to expansion. Unrestrained concrete will not crack. If it's unrestrained, you're allowing it to move. But you got to remember, when it's very long, it's restrained because of the length. So you've also got the subgrade and have friction. Okay. Several sources of restrained cracking. Restraints are drying shrinkage. Anything that dries has to change volume. Reinforcing steel. Okay. You're looking at concrete. You're looking at steel. Both have different thermal coefficients of expansion. The concrete is being held by the steel. Many times you'll notice cracking in a regular pattern sometimes. And if you look at that pattern, it's probably because of reinforcing underneath it. Interconnected parts of a concrete structure. You've got an old structure You pour a new concrete up against it, it'll crack. If you have one crack on that existing concrete, okay, you've got one here, this is an old pavement, you widen your driveway, for example, and you poured a strip because you want to widen your driveway now to 2 cars parking. So you pour a concrete strip here. This one has cracks, let's say. If you don't put a joint where that crack was, you're going to get reflective cracking across. The next time you get a chance to go in through the exit of building B, okay, just underneath the walkway, building J, you'll notice there's some concrete pavements by that parking lot that have been expanded after time. And you'll notice one slab, the joint patterns are different, but from the existing slab, the main slab that takes you up the stairs comes right across. So if you're ever at the college, if you're ever walking downtown, look at the joints, look at the streets, look at the pavements, and you'll see the cracking, okay? So you've got an interconnected part of concrete structure, and it just jumps across. And subgrade friction, drag, okay, subgrade drag. So those are 4 key areas where these sources or these contribute to restraint, okay? Any questions so far? Saw that on southbound PTA 75 last year, right? Yeah, you'll see that. Okay. The amount of drying shrinkage can be reduced. Now, I was going to put a couple of these questions on the last quiz, but I figured, well, we never really covered it. But knowing mixed designs and knowing why we're using less sand, more coarse aggregate, obviously for strength, but obviously to reduce shrinking. The more sand you have in a mix, the more water you need, right? More surface area. More water, more shrinkage. Less water, less shrinkage. You yourself know. Use as low a water cement ratio as possible. Okay? But then you may have problems with workability. So you come up with water reducers, high range water reducers. By the way, some of you on your quiz stated super plasticizers as one of the admixtures, and you also stated water reducer as an admixture. Well, they're one and the same, so you didn't get a mark for it. Super plasticizers are just high range water reducers, okay? So you got regular water reducers, low range, WRDAs as we call them, water reducing admix, and you got the super Ps. And then you've got the exceptional flowable super Ps that gives you flowable concrete. No, where you don't have to even vibrate. Okay. Anyway, so you want to use a low water cement ratio as possible. High range, same thing. That's right. Use minimum % of fine aggregate. There we go. We cover that. You want clean, well-graded aggregates. Water reducing admixtures will help the amount of water you use, and use low slump concrete. True. For example, highway construction, if you're going to use a slip form paver, you're probably only going to be looking at a maximum slump of about 25 millimeters. Anything wetter than that, the concrete is going to start slumping up the back of the paver. You don't want that. Remember, slip form paver, there's no forms on the side. It just extrudes the concrete. So this is a bad picture. It's supposed to just show a typical joint in pavement, but we'll have other ones, okay? So these are the sources. We looked at the sources of restraints. Now we can look at ways of decreasing the amount of drying shrinkage. Okay, so there's 5 elements there. Okay, we're going to look at joints. There's basically 4 types of joints. Okay? Construction joint, exactly what it states. If you're casting a concrete driveway and all of a sudden it started to rain, and you said, hey guys, let's put a bulkhead in here. We'll stop. We'll continue tomorrow when the weather's better. So you're going to put a construction joint in there. You're going to put a bulkhead in, a form. You're going to pour the concrete up to it, and you're going to finish off what you poured that day or placed that day. I hate using the term pour, and I use it quite a bit because it's accepted. To me, if you say you poured concrete, it sounds to me like you were pouring it so exceptionally wet. Placement. It's the same thing with asphalt and asphalt. Okay. We pour concrete. Yeah, we do pour concrete. But to me, every time I look at pour, I figure, oh boy, the guy's pouring soup. He added way too much water to the mix. You place the concrete, it's a little different. But anyhow, you're placing concrete. you put a construction joint. That's exactly what it is. It's like a butt joint. Sometimes they can be connected, tied together, sometimes not. Okay? They are not intended to be used to accommodate the movement. Okay? You can highlight that also on yours. They're there. They're not a control joint. They're a butt joint, a construction joint. At the end of the day, you can tie them together. Here's a butt type construction joint with dowels. Okay, so you're going to set up a form in here because you're finishing for the day, and you're going to have a hole through your form. You might just put a wooden bulkhead, and you're going to have your dowel going through it. So the next day, you strip the form work off here, and you can continue. But here you've got a solid reinforced or tied butt joint. Okay, it's a smooth finish, and because you don't want it, you're going to have a smooth dowel to prevent bond. Okay, if you've got a dowel in there. Anyhow, this is a smooth dowel. This one down here is called deformed, and that's the one that has the ribs. You've seen smooth dowels that are just a straight round bar, and then you've got the one with the spiral running around the perimeter of the dowel. Okay, and these are deformed bars. These tie it together. It's not a contraction joint. It's not. You don't want it to open up. You're just tying it together. Okay? You'll see this. Sometimes they'll form that with an edging tool. A lot of times they'll just cut it after. But anyhow, just for keep the joint space. So this is a construction joint. Construction joint should be positioned at the location where the introduction of the joint will have the least adverse effect on the structure. So a lot of times when you're placing concrete and you're going to place it, you're going to finish it for the day. You're paving highways. You're going to do maybe a kilometer today. We say, yeah, we'll do a kilometer today. Already you're planning where you're going to be ending off. Okay, you want to put that construction joint in its place. You don't want to have a joint 2 feet from a control joint. Okay, so you kind of plan already. And so these are called construction joints. This one here, I believe, was taken out of the city of Winnipeg. You may or may not see this many times now. Keyways, okay? When the concrete is formed, they'll have slip-form pavers that can actually do that on its own, or they'll put it into their form. In other words, if you were going to be forming the concrete, you would nail a nailer strip there so that the next concrete, you have a section. This is going to prevent upward movement, okay? It's a keyway. Reinforcing will prevent that also. So some you'll see will do both, a keyway with a dowel. Sometimes you'll just see the old keyway. I don't see too many keyways now. It's basically just reinforcing steel. But here, this is it. And again, these pavement joints are usually going to be cut and then filled with a sealant to prevent intrusion. Okay. Construction joint. Expansion joint, isolation joints. You don't see too many expansion joints in concrete pavements anymore because of the spacing of your control joints. Expansion joints has got to, if you put an expansion joint in, that means it's going to open up a contraction joint somewhere. Isolation joints are if you want one slab of concrete to behave independently of the other one. In other words, your driveway leading up to your garage floor, how many have got their driveway tied into the garage slab? Anybody? Can you remember? If you guys maybe Port Joe? Okay.
No one would.
No one would, but yet I've seen it. They say, well, I'm going to tie my driveway to my garage slab so my driveway doesn't pull apart, doesn't pull away. You're right. No one would. I wouldn't. Why do it? You're going to have two different movements. You're going to have cracking there. Your reinforcing is going to restrain it. Okay? It's got to let go somewhere. Concrete's going to crack. You want them to move independently. So if I'm pouring my concrete up to my driveway entrance, I would put a bond breaker in there. What a lot of people used to call buffalo board, impregnated asphalt fiberboard. You've seen that. You place it in just a little bit below the surface, and you can run a bead of caulking in there after. So it's independent. You don't want to tie it together. Expansion joints permit movement of a concrete member due to volume change. So your driveway will probably go, if it's a newer driveway compared to your garage slab, it's going to behave differently. It's going to have volume change different than your garage slab. These are usually constructed by installing preformed elastic resilient material, or fiberboards as we call them. And here's a sketch of it, okay? Here's concrete that's existing. You're placing a driveway or a pavement. You're going to put that bond breaker board in there, and then you're going to seal that just so the moisture doesn't get in and play havoc with it. Research indicates that if transverse contraction joints are closely spaced, then expansion joints are not required. And in one of these articles here, the tech brief, I think I put up here for you guys. This one. It's internal curing. I'll put it up another one. There's another research one where it actually shows the same thing as what we were just talking about here. If you've got properly spaced contraction joints, then expansion joints aren't needed. Then isolation. So expansion joints can be different than isolation joints. Okay. Expansion joints might be every fourth or fifth. They used to do every fourth or fifth contraction joint in a sidewalk. I don't know if some of you guys may have been walking down a sidewalk in wherever, older parts of Winnipeg, and you'll see, if you look at the joint, you'll see maybe every fourth or fifth joint, you'll see a fiberboard in there. Some will just even put a piece of plywood in there. And then you'll have another 4 or 5 slabs, and then you'll see that fiberboard again sticking up. Well, that's an expansion joint, but you don't need it. If your contraction joints are properly, because remember, contraction joints movements both ways. Okay? Contracts, expand, contracts, expand. So expansion joints are not required, and that's why we don't use them anymore. You hardly ever put them in now. An isolation joint, yes. You're allowing expansion of this concrete slab to expand and contract without influencing your existing structure or existing concrete. Okay? So that's an isolation joint. Contraction joints. These are the ones that we saw cut 3 meters, 4 meters, whatever. Okay? These joints are used in long lengths of pavement slabs placed in one pour or one placement. They provide a weakened plane to induce cracking. You're telling it where you want it to crack. They're also called dummy joints. You may look at it and think that's a dummy joint. One of them could have been a construction joint. You don't know from the surface, okay? For sidewalks, usually 1.5 to 2 meters. Roadways, 4 to 6.5 meters, depending again on the width of your pavement. Okay? How many of you have noticed parts of Highway 75, or maybe the older parts of Highway 8 and 9, highways got their contraction joints, but they got them on a skew, on a diagonal. Okay? Instead of going 90 degrees to the longitudinal, they swing out maybe 30 degrees, 60 degrees, not quite 45, but maybe 30. Maybe anybody notice that on Highway 75?
Hey, John,
Yes.
what's the big difference on 75, like on our side of the border opposed to the state side? Like, what's the big
Money.
difference you do in concrete?
Money,
Yeah.
probably. You're talking that their pavements seem in better shape or what?
Their interstates are immaculate compared to our highways.
The states are really, really proud. After World War II, the states started to rebuild, okay? And they started the infrastructure, the highway network started to increase. People came back, money was good, people were well off, they were buying vehicles, whatever. And they decided to really put money into their interstate, and they still do, their infrastructure. Their way of construction, I mean, Grand Forks, North Dakota, South Dakota, I mean, weather conditions are very similar to us here, but they do things differently. They put the money in. They started recognizing drainage, I think, a lot sooner than we did. So they put a lot of drainage into the pavements, consideration into pavement. They also put in earlier rehabilitation for the load transfer dowels. And this is one of the things we're talking about joints here right away. Remember I mentioned how is the load transfer from one slab to the next with a dowel. It's by that crack. Okay, you put a saw cut in it and you said crack below here. Any of you know that crack won't come down nice and smooth, will it? It'll be jagged. Okay, so just look at my fingers if you can see, eh? If this is a crack, it's jagged. But I've got interlock. Okay, it cracked. But this one fits into here, this one kind of fits into here, okay? So the pavement cracked, but it's still locked together. Internal friction between the peaks and valleys of the crack. That's aggregate interlock. Crack interlock, if you want to call it. So when a traffic is moving in one direction, it's leaving one slab going on to the other. The slab that you're starting to cross into is going into settlement. The one that you're leaving is rebound. Okay, so there's movement. But you transfer the load across the crack, and the crack below that saw cut is transferring the load. But that only works really well if you've got thick pavement, airports. We relied on aggregate interlock for a long time, but then our traffic volumes increased. Our big B trains, semi-haulers now, they're pulling trailers. It's not unusual to see two 60-foot trailers, okay, on one pup. So as we're going down the highway, the loads and the frequency of road traffic really increased in, say, in the last 10, 15 years. We didn't have enough pavement depth, okay? So now we're putting in dowels. So if you're going to reduce the pavement thickness, you got to put dowels at airport. Okay, they got big jumbos, but those pavements can be 450, 500 millimeters thick. 250 is 10 inches, okay, 20-inch pavement. So they're relying on that aggregate interlock when that plane is coming over. So the states have really put a lot of effort in sooner than what we have. They probably had more disposable income too. Okay, more money. They got the money. The powers to be probably look at the infrastructure as being very important for the well-being of the economy, and they put money into infrastructure. Here, and especially in Manitoba, we don't put in nearly enough money into the infrastructure. We just don't have it, and the feds only give you so much. Yeah. But if you have money, there's not too many things you can't do without it, right? You got money, you can go up to Mars. Roadways, 4 to 6.5 meter intervals. Okay, does that explain it? To me, it's just the money and they're ahead on their design aspects than what we are.
Hey, John.
Yes, sir.
You were talking about the control joints that weren't perpendicular. Did you
Right.
end up answering that question? Because I know
will
the number
now.
one highway is also like that.
Yeah, highways did it, and it's not a bad thing, but now they're getting away from it. You ever hear road chatter when you're going on for a long trip? You always hear that burp, 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 burp. It'll put you to sleep if you're driving for a long time, right? It's repetitive because every joint is, especially if they didn't stagger the. So what's also happening from that respect, the other reason is that one wheel only crosses at the same time. So when you're starting to load a slab, only your front wheel, say your left wheel, will cross, sorry, your right wheel, if you're going southbound, your right wheel will cross first, then your left wheel, same with the back ones. So you're loading and unloading a slab with less weight, plus you're not getting that repetitive hum. And that's why highways, even on number one and elsewhere, you'll have a 3 meter spacing. Then you may go to 4 meter spacing, 5 meter spacing, and then back to 3, 4, 5. It breaks up that repetitive hum, okay? But also they used to put it on a skew, believing that, and there was some truth to it, that you're not loading the slab totally with the whole front wheels, and the next wheels, and the next wheels. You're distributing the weight a little bit, say in half, well, maybe not in half, but you're distributing the weight from one slab to the other one, but not such a great amount because only one wheel is crossing, then the next one, then the next one, then the next one, then the next one. Okay? But you'll notice they didn't do that at Centerport. They just went straight 90-degree cuts to the longitudinal. I don't think it's a bad idea. You know, you don't see it anymore in new construction, at least. I think highways took it out. They used to do it all faithfully all the time. That explain it? Okay. Joint should be a straight line perpendicular to the alignment of the roadway and can be filled with a flexible joint sealant. And you'll see that. Okay, the guy places the concrete, and you'll see that as you're placing concrete, especially if you're placing concrete for 10, 12 hours a day, you start at 6 in the morning, okay, and everything's going good, you've got good delivery, there's no hang-ups, there's no delays, you're just moving along at a nice rate, nice pace, and you'll see that the night crew, if you want to call them, comes out. At about 5 hours, you'll see the guy drag out the big pavement saw, and he's already walking on the pavement, and he's checking it. He's looking down to see if he's putting his footprints in it. He's ready to start cutting. Okay, he brought the crew. So he wants to start cutting that pavement, even though they're still placing concrete further ahead. And that's the key. If you pour a concrete driveway on a Friday, the contractor says, okay, I'll come back Monday and cut it. Tell him to give you a credit and not to bother. Too late. Too late. Concrete's already got 2 days of shrinkage. It's got to let go somewhere. Yeah, he may be cutting at 8 o'clock, 9 o'clock at night. If you poured Friday morning, you poured a nice double wide driveway, 50, 60 feet long, say 20 meters, whatever the case may be. If he's not cutting it, if he's not checking it within 5.5, 6 hours, again, depending on the ambient curing conditions, hot, cold, whatever, sunny day, windy day, then you want to cut it as soon as you can get on it. You want to relieve the strain. Okay? So we have to cut it at an opportune time. You don't want that concrete to undergo such extreme shrinkage or restrainment that it's got to let go somewhere. Okay? So you're going to cut it, and then usually you'll seal those joints to prevent intrusion of water, debris, and so forth. Penetration of water and debris. These joints are usually constructed by 2 methods. Installation of a strip into the plastic concrete. That's pretty hard to do. Get it nice and straight. On a sidewalk, you can do it when you're only looking at maybe 1 meter wide, 1.5 meters wide. Try and do it when you're looking at 2 lanes of traffic. So they'll usually come in with a diamond saw and they'll cut it. Okay? They'll know where their dowel assemblies are. They know where their low transfer dowels were put in because they know ahead of time where those control joints, contraction control joints have to be. They'll set up their saw and they'll cut it. They'll also cut a longitudinal. If they're paving 2 lanes at a time, and some of those slip-form pavers can, then they also got to cut the longitudinal joint. The flexible strip would be great because you can do it right when the concrete's wet. Then you know it's done. It's already created a weak link there. But they're hard to get nice and straight. Okay, so the guy will come and cut, but you want to cut. You have a brief window when you can get in there to cut. You can't get cut too early because the concrete won't support you and the saw. But if you wait too late, it's already shrinking. And that happened on Highway 75 when I was there. Contractor was cutting the joints, and one of the highways inspectors noticed in the morning when he's driving down that pavement. It wasn't open to traffic, but it was already had enough age that we could use our service vehicles up and down. And it rained early in the morning, and then it got sunny, say around 7, 8 o'clock in the morning. Pavement starting to dry. Okay, but your joints are going to be what holds water, so you'll see that all the time. And he always saw water going across the pavement, but it wasn't water; it was a crack. Okay, now the crack was wet. So as he's driving down the pavement, it's dry. It jumps out to him. He sees it. Hey, what the heck's that? So he stopped. And what had happened is the contractor was cutting his transverse joint. And then before he went right across the pavement, it snaked off and cracked. It was at that opportune time when he was at the end of his window of cutting. So now you had a control joint going across the pavement, and then all of a sudden a crack snaked off at the edge of the saw cut across. Okay, so now MI is telling the contractor to take the whole pavement out, a section of pavement, and he refused to do it because he said there was nothing wrong with it. I mean, that's one of those things. There's that opportune time. You got to be able to get onto that slab, and that's where this opens up so much more. There's what's called early entry saws. Okay, there are saws now that you can cut green concrete. You yourself may not be able to walk on it, but you can put the saw on a long dowel or a long handle, and you drive it across. And it's got a paddle between the blade, almost like a sewing machine holds the fabric, and the needle when you're sewing, it holds the fabric down. Well, as the diamond blade is cutting across the concrete, you have like a shoe on both sides of that blade holding that, and that'll help the concrete from chipping out. If concrete is too green with a conventional saw, you're going to get a raveled cut. Aggregate's going to start chipping out. Okay, concrete's going to be wet. The blade won't be able to cut very well. It's always easier sometimes to cut meat that's a little bit frozen as compared to meat with a dull knife. If it's already thawed, you can't get that nice cut. Well, same thing. If the concrete is too green, the blade is going to ravel that joint or that cut. So they call what's called early entry saws. They're lightweight. You yourself don't have to go on it, but if you had a straight edge to follow it, you just push it across and it'll cut. And those you can start cutting, some of them say within 2 hours of placing concrete. And then you don't even have to cut as deep because you're cutting it early. Early entry saws, there's a brand name for it, and it'll come to me later. It's like everybody calls a snowmobile a skidoo, but they're not. It's the same thing as the saw. There's early entry saws, but there's one brand that sticks out and it just slips my mind now. It'll come later. Anyhow, so we want to make sure we get on it at the proper time. You wait too long, concrete is going to start cracking. Go on too early, and you won't get a nice cut. So you'll notice these contractors, their sawing crew will come later, and they're going to work. Sometimes on Highway 75, they're cutting into 1 o'clock to 2 a.m. They're using big floodlights because they got to cut. If the contractor finishes his bulkhead, his 2 kilometer or 1 kilometer stretch at 10 o'clock in July or August, that's 10 o'clock at night. That means the guy's probably cutting 2:30, 3 o'clock in that area towards the end. So they cut all night. That's the proper time. Do that at home, and you're going to have some pretty irate neighbors that are trying to sleep, and you've got your RGA, Sean. Oh, that saw's not called Bombardier, but yeah. Okay. Joint should be at least 1/3 or 1/4 of the slab thickness, okay? And it should be full depth across. You'll see a lot of times contractor doesn't like cutting them because he's got nice plywood forms. On a driveway, he may want to reuse them. So he'll start cutting, but he'll stop short of the wooden plywood form because he doesn't want to cut it with a saw. So really he gets a curvature near the end, not 1/3 right across. That's a no-no. You got to have 1/3 right straight through. Because if you take your forms off, you'll see that on the edge you might only have a 1/2 inch cut, if any. And then it goes like a bird bath, like the bottom of a dish across the pavement. So you want to measure 1/3 to 1/4. That's easy enough to measure. When he cuts, you go back the next day and you just put a shim in it, pull it out and measure it. Okay. So here it is, you got a saw cut 1/4 deep, and there's a crack induced below it. And they'll usually put some form of hot sealant. And here, these are the dowel assemblies that I referred to. Okay, these are the load transfer dowels. And here you can see on the pavement the joints cut. So they're doing the next lane here. Here you can see he's got the longitudinal joint. Sorry, longitudinal mean tie bars to stop the longitudinal joint from opening up. And then he's got these dowel assemblies. These are epoxy coated rebar, which to me is garbage, but everybody thinks it's the next best thing to slice bread. To me, epoxy dowels aren't any better than non-epoxy dowels, and yet you'll see the city placing them and everywhere else. Sometimes referred to as a basket, okay? Here you can see that these are tied, these pins. These bars are going to be allowed to move. These will be cut later. These are just shipping wire. You can see that they're holding the cage together. So you place it in, you pin them down here with the pin so the paper doesn't push them out of the way, and then you'll cut these. Okay? Because if you don't, you're restraining the movement. So you'll cut these. Okay? And you can see these assemblies have been sitting probably outside in the rain, or they got a little bit of flash rust, but it's nothing serious. Dowels must be fabricated and installed in a manner that permits the joints to open and close with slab contraction and expansion. This is typically accomplished with relatively smooth dowel surface and generally requires the application of a bond breaker. So you'll notice that a lot of these bars, you'll notice the contractor, if they don't come from the factory with a lubricant, or if they've been sitting too long, that lubricant may dry out, he'll have to lubricate these again, because you don't want these to bond. Because if the concrete bonds to it, it can't expand and contract. Okay? So these are putting load or transferring the load across the joint, because that's a weak link, okay? So you're just transferring the load from this slab to this slab. Now, if these were, say, deformed bars and they weren't greased, now you're bonding them, now you're tying them. They can't move. You're just restraining it again. Okay? So you got to allow the concrete to move both ways. All that reinforcement does is transfer the load, because you don't have the thickness here to allow the crack to transfer. Remember, aggregate interlock, or crack interlock, to transfer the load from one. Okay? So you'll see these put out, and there'll be marks, so then when the contract, like these were in first, and then he knew where to put the saw, so he cut that right down the middle. These are pretty straightforward now. Now when the guy's placing his saw, he knows that it'll just come right across, same one. Okay? Longitudinal joints. This is the longitudinal, divides the lanes. And there's two reasons why we do it. Okay? You want to control the cracking and separation. So in other words, if you're paving, your slip-form paver is really wide and you're pouring 2 lanes at once, you got to cut that longitudinal. So that's to control cracking, because concrete also is going to shrink both ways, widthwise and lengthwise. And if you're pouring 2 joints, you want them together, because sometimes you've seen that where the longitudinal joint has opened up, and there were sections on the Highway 75, it opened up so much, and then we had differential settlement. So if you were on a motorcycle and you hit that longitudinal joint, I think you went over tea kettles. Would you only grease half of them? You've seen that, yeah. Some will grease half, still allows pavement to move. In other words, the dowel will move with one slab, but not the other. Some will grease both, so it just kind of lays in between. So in other words, you're sliding along this way, whereas if you only grease one half, that's the side that's going to be not bonded. The dowel will move with the other slab. Okay, same thing. But I think nowadays they'll do it in the factory, and if they're still come in properly packaged, the dowel assemblies and bundled and shipped, they can, and you know that you're going to be putting them in real soon for that coating sets up. Most of them in the factory will just do the whole dowel just that much quicker. Stalker cavity on the west side of Phillips has a longitudinal opened up to about 1 inch. That's correct. Okay, either reinforcing failed or there was no reinforcing, no longitudinal tie bars. We call them tie bars, okay, because they're tying the two together. And that happens. I noticed that on Highway 75. What happened there? We don't know. That's why inspection is very important. And you're also going to have to look later on. Your transverse joints come up to a longitudinal joint, right? Now, if you look at this dowel assembly, you're going from width to width, right? Now, look at this reinforcing tie bar on the longitudinal joint. See my cursor? If this tie bar is too close, let's say it's here, it overlaps the control joint. You've just wrecked it. You're not going to allow it to move because now you're tying it. So you got to make sure that this first tie bar on each side of the control joint is out of performance area of how the dowels work. So this is important. This distance from your dowel assembly to your first tie bars of the longitudinal joint is important, because if they're too close, they're not going to work independently. Okay, so there's a little bit to it. Now in this case on soccer cavity, who knows, maybe reinforcing corroded. Have you noticed maybe you just noticed it, but have you noticed maybe how long it's been there, or is that just something you just noticed recently? So, and that can be a problem, especially we did a rehab on it. Okay, good. So you're with the city or the consultant. Yeah, you have to, because it could be a dangerous thing on a bike, motorcycle. Cars may not get influenced so much, but it is a problem. And if it opens up and you get water in it and it freezes, expansion, eh? And depending how good the other tie bars are here to control wide movement. Yeah, you got to be careful. Okay. So now we have two reasons: we control cracking and separation, but also if you'll notice, your lanes are usually set up on joint spacing between the longitudinal joints. So if you got a 4 lanes of highway, or you got 3 lanes of pavement, okay, usually there's a longitudinal joint between the lanes. So it's for lane delineation. And where there's a problem, and a lot of people, when they don't see their white lines, they rely on these lanes. But then get down to Keniston by IKEA, where they did a major rehab there. They got about 5 lanes going. And there's no real lane delineation because some lanes are wider, some are narrower. So people driving in there many times, if they don't see those control joints, sorry, the longitudinal joints, or they're trying to follow them, they're hugging 2 lanes. Okay, so I think sometimes we rely on this too much, but it is. It guides your vehicle. Okay, so control cracking and expansion, or separation, I should say, and lane delineation, 2 functions that the longitudinal joints gives you. Longitudinal joints are not required for slab widths of 4.6 meters or less. And if you have a single driveway, basically 1 lane, okay, you did road profiling after diamond grinding and it helped. Pavel? Okay. Yep, roughness index decreased. What did you guys use, a road profilograph or a dipstick? Van with a GPS. Yeah, okay, good. Yeah. That wasn't local here, or did they have to come in from the east? Maple Leaf Construction going. Yeah, well, they're getting big into everything now. I mean, they're also doing the diamond grinding too. They brought that up from the States, so they're doing it now. Okay, good. So again, longitudinal joints are hinge joints. Okay, a key or a tongue and groove, if you want to call it. And here you can just look at the typical orientation. You can see here your longitudinal in between going in. You got your transverse assemblies. You may have sometimes a manhole in the way or whatever the case may be, or sometimes you'll get a lamp standard and it's a little bit wider, whatever the case. But here you can see your string line. The paver follows, the slip form pavers, placing concrete. These are already pinned into place ahead of time. So the concrete is deposited and it can, okay. Longitudinal joints are typically sawed. They can also be formed by inserting and leaving in a plastic tape. That would be pretty hard to do on a longitudinal. Now they've got these slip form pavers that will insert the dowels themselves. They'll insert these dowel baskets. So what they really do is they don't insert the basket, but as the paver comes across, okay, all of these dowels will then be pushed into the pavement, okay, through the surface, and then the vibrators behind it will make sure that it's all vibrated in and closed. So this operation is going to go before the vibrator in the slip form paver, because slip form paver places the concrete, front augers, keep it level, goes through the machine, vibrators, consolidates the concrete. But in this case, it's going to consolidate after these bars are pushed in. So those are called self-inserting pavers. And they'll also do that to the longitudinal joint. And it's programmed that as the machine is traveling, the longitudinal joint gets dropped in. And another one comes around and gets dropped in. As it's moving, another one comes and it's dropped in. So they all got to be systematically timed, these machines, such that you get the proper spacing. You can always go with ground penetrating radar after and scan the surface of the concrete to see if these dowel bars are in the proper place. And MI has a system like that of doing it. Okay. So again, the equipment is getting more automated. So a lot of this doesn't have to be done ahead of time. It does as one operation. So these slip-form pavers are pretty fancy machines, some of them, and they can do a lot. So self-inserting slip-form pavers. And again, here's a typical tie bar basket. Now your longitudinal joints, these tie bars are going to be deformed, okay? Because you want to tie the two halves of the pavement together. The dowels are smooth bars, okay? Because you want the pavement to contract and expand at the control joint. The longitudinals, you want them tied together. And here you can see another sketch which shows a continuous length. Now you can see here, usually there's room on the side. And this is where the paving truck can back in, the revolving drum mixers, or the dump truck. If you're using a dump truck, then the paver is going to have a bucket where he can move it over and then dump it. If you're using revolving dump trucks, he'll come in here, he'll swing his chute out, and they're usually pour from both ends, and make sure that he meets halfway. The truck on the other side will halfway. Plus you got that auger, okay, the auger in front of the screed of the slip-form paver levels the concrete back and forth uniformly. So you'll see there's got to be room here for the trucks. At Centerport, we were restricted. So as we were pouring, these guys had to quickly slam these into place, pin them down, cut them, then we paved up to it. And as we just got past it, they put the next one out because the ready mix trucks were backing in and they had no room on the side. So they actually had to travel down the grade that you were paving. Okay, so that's it for joints. We're going to take a little bit of a break here before we get into curing, but this is just a very preliminary. There's more to joints design, the spacing based on slab thickness. Do you go with how big should your dowel bars be? Okay, load transfer. Should they be 25 millimeter? Should they be 40 millimeters? Should it be 16 millimeters? Okay, depending again on the type of pavement. Is it a residential pavement? Is it Highway 75? What kind of traffic? What kind of thickness? So there's also the design of it, which we're not getting into. We're just looking at what the role of those dowels are and why we join concrete. Because we know concrete is going to have volume change. And with volume change, you're going to have stresses induced. You're going to get cracking. So we got to acknowledge that. There's a couple of articles, reference articles I think I've uploaded. You may want to look at them. I can also upload more. There's lots and lots about joint configuration, width of a joint, how wide should a joint be as compared to its depth. Okay, there's a very important. Okay, because it depends on how that material in there works. Typically, you want bond in a joint on the sides, not the bottom. Okay, same thing when you're using caulking. Okay, I'm going to usually tool it, okay, below the surface so you don't rip it out. But you only want bond with the joint on the sides, not the bottom, because then you got to have some elasticity in your caulking material. Now you're looking at caulking and the manufacturer of caulking and its performance. So when I was in the restoration industry, it was important for us to know what type of caulking we're using, its elongation properties, its adhesion properties, its cohesion properties, and what's the width of the joint? What's the amount of movement that joint, is going to undergo? So we have to pick the proper sealant. Does it have the proper elongation properties? Okay. Typically our highways, we're using a hot poured asphaltic type of bitumen, and you'll see them gunning it out in City Winnipeg or even on MI. It's cheap, it's messy, it stinks like crazy on a hot summer day. It's asphaltic bitumen, but it's cheap. Money talks. If it's going to perform the job, they'll go with the cheaper one. May not be better. I mean, as long as it performs the job, you can also get a superior. You know, an Impala is going to get you from A to B, but so will a Rolls Royce. Which one are you going to pick? How much money have you got? Okay. Okay, let's take a break. It's 10:22, so we'll come back here at, say, 8 minutes enough. Come back at 10:30, and we can round off curing, and we'll be done. Any questions so far as joints? It's very brief. straightforward. I highlighted the key parts. Okay, we know the 4 types of joints. We know what they're used for. Okay, let's take a break here. We'll see you here at 10:30. I'm just going to pause the recording, but I won't. You can just come right back. I'm going to leave this open. I'm not going to create a different WebEx. Okay, there's nothing else. We'll come back and we'll look at cheering.
Hey, John,
Yes, sir.
for this midterm coming up,
Yeah.
it's just unit 7, 8, 9, 10,
You bet.
and it's
Typically-
just theory.
Well, yeah, because there's nothing here for design calculations.
Yeah, that's what I was noticing. Okay.
Yeah, no, it'll be strictly theory. It's just the units. Typically, the midterm would have covered everything that we've covered. It would have been all of concrete. But, that's had we been face to face and we had more time. But because of, reduced hours, reduced content, I'm just saying, okay, the midterm is just going to be the last units that we haven't been tested on, which are the last 4 units. And then when we get into asphalt, it's the same thing. We'll see where we end up at the end of April for the final exam. I don't think the final exam will be all of the asphalt, but it may be half of the asphalt, depending how many quizzes I have in between and what I cover with the quiz. So if I covered it with a quiz, right now I'm looking at the fact that there's no need to revisit it again. Different when we did face-to-face. Okay? Any questions? What about feedback for test 2? I can give you back the test if you want. You should have your marks back. I usually give back the quizzes because a final or a midterm usually covers for the whole year. So you can use your quizzes as a study media. Okay, it's a resource for you. I don't need them. It's more beneficial to you. But really, your quiz 2, you don't need to know anything from quiz 2 for the final. Sorry, for the midterm, not final. Sorry, for the midterm. I can give it to you if you're curious to see where you went wrong. Most did well, lower than expected, someone said. See, a lot of times I think things may not have been referred to again. It's a good sometimes to go back to a recording. But anyhow, I can return them for those that want. It's a big job to return them all, but I mean, I can do it. I can do it for those that really want to see it. Those that almost got 100%, well, I can do that too. If you really, really want to know where you went wrong. Okay. Usually I give them back when we had paper copies, face to face. I would give them back to you guys. I know other instructors let you see them, but then they wanted them right back right away. Those of you that may have had Dr. David one time, he was quite explicit about that. He did not want you to keep them or take a picture of them or anything else. I change quizzes from year after year. A lot of instructors use the same quiz over and over and over, and they don't want it to get into the hands of the students because you may pass them on. I change them. So, say, I've got a lot of quizzes out there probably that they may have been floating around. I don't know. Okay, tell you what, for those that don't necessarily want to see their, just send me an email saying you don't want to see it. It's going to save me some time and sending them all back. As you'll notice, I don't necessarily mark through the Dropbox. I don't like the features. So I save them to my documents, I'll mark a PDF, and then I send them back to you. Just like I do the labs. I don't mark the labs in the Dropbox. I take them out of the Dropbox, put them into my own folders. So when I send them all back to you guys, your labs, I physically got to send an email to each group, as you guys well know. But if you want them, I'll send them to you. If you don't want them, just let me know and it'll save some time. Okay? Okay, it's now 10:26. So let's come back at, I got to grab a coffee and make a phone call here. So let's grab 10:35. Okay? Okay, we might as well get started here. Set up the recording again. Okay. Now that we've got our concrete all placed and cut, You can just keep on curing. And curing is going to take on indefinitely, okay? As long as you have moisture, you've got temperatures that are favorable, and you've got time, curing is going to continue. It'll continue, continue, continue. If there's cement to hydrate, obviously, if all the cement gets hydrated and there's no more cement to hydrate, then curing or concrete strengthening is going to stop. So these are some of the key things that we need when we're curing concrete. You've got to have moisture, you've got to have ample time, and you've got to have favorable temperatures. If you don't have one of those three, curing is severely retarded. It's stopped or greatly reduced. Okay, so let's have a look at some of the curing aspects. Okay, I'm going to just back up here a little bit. Okay, everybody can see that. Get the chat out. Curing concrete. This is one of the key aspects of concrete. If you don't cure it, you're not going to get adequate strength. You're not going to get adequate performance. Durability is going to be greatly affected. Abrasion resistance, strength development. And this is one aspect that's severely overlooked. Not only from a private point of view, where I think most of it is, but even, say, from a commercial point of view. Sometimes it's not understood enough. And that's the problem. And we don't do sufficient curing. When I was down in San Antonio, I was listening to a technical rep from one of the manufacturers of the liquid forming membrane curing compound companies. I think he was with Degussa or Grace. And you've all seen the technical spec sheet where it tells you to apply the curing compound. You've seen them. That's the white curing compound they're spraying on the pavements, or green. Some of them are green colored. Even the technical data sheet that the manufacturer come up with isn't adequate. Now you get a range. So many liters per square meter, or square meters per liter, whatever the case may be. And you've seen the contractors apply it on a small slab. They'll have maybe a Chapin sprayer where they're pumping it, pressurizing, and then they're using the sprayer, and they almost like when you're spraying for weeds. Okay, but it's got curing compound in it. And you'll see him spraying it, and then he wants to reach the other side, but he can't because it's a wide pavement and there's no place to cross. So he just puts his wand out as far as he can, and you'll see sometimes they'll rely on the wind, try and place it, but the wind blows it onto the lawns and onto the grass. That's not good, guys. That's not good. How many of you guys actually inspected pavements, whether it's rehab or new pavements, and you've witnessed, or the specifications stated, to use the curing compound? Anybody? Yes. Okay, Fabian. How much did they use? And did you check your quantities? Were they putting on the right amount? You can open up your mic if you want. Usually not enough. So you have to mention to them to go back over and put some more down, right? Was it up to you to ensure that the back of the curb got sprayed? Why did they leave it? Why didn't they do it? And they went back and did it, right? So what's that got to do with it? When is it going to get covered? 3 weeks later? When are they going to backfill and open up the pavements? 3 weeks later? 4 weeks later? So meanwhile, part of it is cured, part of it isn't being cured. You're losing moisture out the back end. So really, if you're spraying the front, what good is it? Didn't you just waste the money there and achieve nothing? So why'd you guys pay him? Why didn't you say no? There's a deduction. You didn't follow the specs. How much did they put on? Obviously, they weren't, for the amount of concrete placed in square meters, they didn't put on the proper application. Why are we testing slump, and why are we also upset about air content and temperature, and we reject concrete because the slump's 20 millimeters over or 40 millimeters over the spec, and we're all up in arms. Strength should be the last thing we worry about as far as pavements. There's more important factors than just strength. If you can't come up with a mix now that's going to give you 32 MPa, I mean, close your door and go home as far as a ready mix producer. We go overboard on that, but yet one of the most important part is that 32 MPa concrete going to get you 32 because you're not curing properly. Okay, so this is where I'm coming from. We're overlooking the important parts. We're designing concrete for 32. You guys took all this time and you designed it for 40 MPa, 0.34 water cement ratio, because we had no data. So we wanted to make sure that concrete is going to reach 40 MPa. But yet, it may not because it's not cured properly. We allowed the moisture to evaporate. On small jobs, you can cover it with sheet goods, plastic, and keep the moisture in. But on how you cover a kilometer of highway pavement with plastic sheeting, you can't. Well, you can, but it wouldn't be very practical. Plus, the wind would have a heyday with it. Okay? We have to look at it, and you guys, a lot of you guys are going to be working as contract coordinators. I don't know if they like to use the term inspectors anymore, but it's up to you to ensure that the goods are provided by the contractor. We spend time and money on specifications to try and let the industry know, the contractors know what we're trying to achieve. Our client wants this, our pavements. We want our pavements to last. So if we overlook one of the most important parts, which is curing, are we getting a value for the money we're spending? You're gonna get arguments from contractors because they don't understand. And the guy working the chip and sprayer, even if you covered every surface, the back of the curbs, maybe, do they put enough on? If you see the gray pavement peeking through, they didn't. Some specifications will tell you to cure your first layer with green curing compound and then go over it with white. And if you see green sticking out, you haven't got total coverage. If your pavement looks gray and not white after you spray it, you don't have enough coverage. You gotta keep that moisture in. So we use a curing compound. It goes on like a liquid, but it'll skin over. Okay? It's membrane forming. It's a liquid membrane forming curing compound. And then with traffic, eventually it wears off. But for the time being, before we put traffic on it, it'll skin over. It'll create a rubberized, if you want to call it, a flexible membrane. And will work like a sheet of polyethylene if properly installed. Okay, curing concrete. Good job, Fabian. Come on. Okay. What is curing? Well, here's the definition. It's the maintenance of satisfactory moisture content and temperature in concrete for a period of time immediately following placing and finishing, so that hydration and the desired properties may develop. Okay. Key content, moisture content, temperature, and time. You got to have all three to get good curing. And you got to have satisfactory moisture. We don't cure for 1 day. We don't cure for 3 days, depending on the concrete. If it's structural, sometimes you got to cure for 7 days. And there's CSA standards that tells you based on strength and in-service situations that you're using that concrete for is going to dictate the length of time you're curing and what you use for curing. Okay, so essentially the three adequate requirements is moisture, temperature, and ample time. Not just time, ample time. 1 day is not as good as 7 days. If any of these factors are neglected, the desired properties will not develop. Begin curing as soon as concrete stiffens enough to prevent marring or erosion of the surface. Okay. Many times you'll pour a concrete driveway and the guy will say, contractor will say, well, just keep spraying with the garden hose. True, if you're not going to cover it, you're going to have to keep an eye on it because on a hot day, you spray it, water's just going to evaporate. So if you can put burlap sacking down or any type of material that'll hold moisture, and you can see here on this bridge deck that it's sheet goods. They're using wet burlap curing. For bridge decks, your curing compound isn't going to perform as well. You're sealing the moisture in, but what you're doing here is you're sealing it, plus you're giving it excess. Okay, you're supplying it with moisture. So there's different methods. Okay, so curing, it's the maintenance. You want to have adequate moisture, ample time, and adequate temperature. What does that do? Well, it increases the strength, the durability, the wear resistance, water tightness. Okay, we're going to reduce the permeability if we keep curing it because the moisture is hydrating. Cement paste and the water is hydrating, creating a gel, reducing the pore structure. Durability, abrasion resistance, we'll call it the same thing maybe. Freeze-thaw resistance, again, related to permeability and volume stability. If it dries out, it's going to shrink. It's going to crack. If you don't let it to dry out until it cures and hardens, your volume change is going to be less. So you want to make sure that you have, and I can't stress that enough, you got to have proper curing. Okay? Effective, adequate curing on hardened concrete. It's best to moist cure continuously from time of placing. Okay? And finishing until concrete has gained sufficient strength, impermeability, and durability. Again, unless you physically go out and take cores and check the permeability, you run hydraulic conductivities on it, you do Tabor abrasive test on it, Tabor dressing wheels to try and get abrasion resistance. This is more qualitative instead of quantitative to prove. I mean, you can do it, but you got to run tests. Nobody does. I shouldn't say nobody does. The research people do. The manufacturers of the curing compounds do. You got to have data to substantiate it. Okay? So if you can give it moisture, some of it's going to evaporate. Obviously, some is going to be hydrated, which is what you want. On a pavement, remember we looked at placement, you're going to spray the subgrade. You'll always see that when you're placing concrete on grade, spray the subgrade down. You don't want water being sucked out of the mix into the dry A-base. You don't flood it such that they have water sitting on it, but you got to make sure that it's moist enough that the water will not be drawn into the subgrade. Keep it in the mix. Let it hydrate. Don't let it evaporate from the surface. Cover it. Stop evaporation. Anything that does evaporate, give it more water. Spray it. Add water. Loss of water can cause shrinkage cracking. It can. We know that. Protect surfaces, including exposed edges and joints, from moisture evaporation. There's that curb. You didn't do the back of the curb? There it goes. You just lost all that moisture. Sorry, not all the moisture. You lost moisture from within the concrete that could have been used for the hydration process. And again, say tables 2 and 20, I think that's still in the new standard. If it's not, but there will be tables that tells you. Okay? And that's under point 1. My favorite, graphs. Come to think of it, that last graph, that question number 35, part C, when I read it and read some of the answers, it got to me that some people were interpreting it wrong. So you'll notice everybody got 1 mark. That question number 35 was worth 3 marks, 1 for A, 1 for B, 1 for C. Everybody got 1 mark for C, regardless of what you placed on it. Because when I kept reading it, I thought, okay, this individual may have taken it this way, somebody may have taken it this way. So I gave everybody 1 mark for part C. A and B worth a mark. Yes or no was half a mark, and then your substantiation. But many of you guys did not provide me data. You made general comments. That's fine. But you didn't back it up with values taken off the graph to show slump loss in relationship to your last time. So you'll see a comment that I gave, if I'm going to be returning yours, that says I need data to substantiate. I can make a statement all I want. But if you don't give me value, show me that there's a slump loss greater with a retarding mix than non-retarded, that type of thing. So you get half for the right answer. Anyhow, you'll notice that. So here's a graph, and I love graphs, as you all know, because they tell you a lot. And here we can see how curing is going to affect compressor strength with the age of test. And here they're looking at even a year of testing, 365 days. Concrete will still cure if there's time, moisture, and adequate temperature. During the colder winters, it'll slow down, may even cease. But if there's still cement that's dormant, there's still moisture, it'll cure. So we look here, and you can see here that 7 days, okay? And like I stated, 70 to 75% of your 28-day strengths is usually developed in the first 7 days. And here, if it's moist cured the entire time, you can see how it's increasing. At 365 days, it got as high as PSI, 1,000 times PSI, almost about 55 MPa. You look at the red, and air after 28 days moist curing. So you're actually curing it for 4 weeks. That's the next greatest achievement. Okay, at 28 days, it doesn't make much difference. But you can see here how it takes off if you keep curing it. 7 days, again, it's only a certain percentage of your 28. And if you air dry it, with no moisture, that's going to give you the least. So here you can see how moisture is affecting the strength. Everybody clear on that? Okay, so effective moist curing, very important. Now temperature. And here you can see casting, curing temperatures. Okay, casting and curing. So 23 casting, 23 curing. You may cast at a certain temperature and cure at a later temperature. Remember, if you're heating and hoarding. And what you're going to find here, that this here is the compressor strength as a percent of the 28-day strength. So you're comparing it against the 28-day strength. And sometimes you can see that at about 28 days, there's not much difference. But it's the earlier. Okay, you've got, that's probably 14 days, this would be 7 days, and that would be 3 days. So you can see that initially there's a fair range on your 3 days, early age. 23, 23, if your concrete was cast and placed at 23 degrees and you cured it at 23, and you've got favorable temperatures. What I like, the purple, is not much temperature differential. In fact, the one that has a temperature differential is 23 and 10. And at 60 days, there's a little bit of a difference. But at 28 days, they're all the same. Your initial strength is low. That's okay. Maybe you don't need it low. So you can see now how curing temperatures has a bigger influence on the earlier days. And that's what we did in the precast industry. Anybody ever work in the precast industry? Precast pre-stressed? In the precast industry, when you're pre-stressing, you want your strength now, within 12 hours, because you want to de-stress, okay? When you're pre-stressing is you're putting tension on your strands If you're pouring girders, you're going to pour the concrete. Then you're going to release them, release the tension. So you've pre-stressed your concrete structure. Well, that concrete's weak, and you cut those tendons, they're just going to spring right out and crack and bust your concrete all to heck. Okay, so you want your strength up front. Plus, it's a assembly line. You want to be able to strip the forms, pick it up, and move it out of the way, and do another element. If you're doing bridge girders and you've got 100 bridge girders to put together, let's say. So you want to So you want your strength up front. So what do? We sock the steam to it. We drive that temperature right up. We lose it on the 28 days, but who cares? Because we want to move that element out of our casting beds. Then we want to move it outside in the yard. It's going to sit in the precast yard for maybe 3 weeks. Then we want to pick it up and move it to the job site by trailer, whatever. So we want, in the precast industry, you want your strength up front. So drive the temperature to it. If the temperatures are too high up front, you're going to lose it on the back end. For pavements, you don't want that. Pre-stress, precast, you do, because you want to be able to move it right away. You want to be able to lift a gantry crane in a precast plant. You want to pick up a girder with the lifting hooks. You don't want that thing to snap. So the concrete strength's got to be there because you're handling it already, okay? So you can see from the temperature influence. Here, the blue is 32. That's the highest. We use steam, whether you use live steam or dry steam in the precast plant, we get these temperatures up even higher than 32. So then you can see here from the 10 being your lowest, then your green is 23, red is 23, and then blue is 32. It's the highest. You can see here at 28 days, it doesn't make any difference. And even here it's lower. But in the precast industry, you want it up front. So we sock the heat to it, okay? So you can see how temperature is very critical for the early age of concrete. This is the effective curing temperature on strength gain relative to strength at 23. So we're comparing it. I'm not going to go into too much detail, but here again, you can see a 10 and 10. Okay, so that's compressive strength as a percent of 23 degrees. See, temperatures are lower as far as casting and curing, but you're still getting above the 28 day. Here's that CSA standard. You don't have to know, but here you can see that tells you the curing type. And you see table 20. Go to table 20, and they'll tell you how to cure it. This HVSCM is high volume supplementary cementing materials. So if you're going to use high volumes of fly ash or silica fume, you're going to have a different curing regime required than you would if you're just going to use normal Portland. Get some more. And here, basic curing, 3 days at 10 degrees or greater. Additional curing, 7 days total. Extended wet curing, like for bridge decks. A wet curing period, 7 days. The curing types allowed are ponding, continuously sprinkling, absorptive mat, fabric kept continuously wet. And you'll see that a lot of times on a bridge deck. Okay, they'll put that white blanket, they'll soak it, and then they'll put poly over it. A lot of times they'll have soaker hoses put right underneath it. And they'll have a night watchman on that bridge deck, and he's checking for moisture. He's there on night shift. You know, he's staying in the field office, and he may go out periodically, and even on a hot summer day, and then a fairly warm evening, he's got to make sure that that bridge deck is continuously wet for 7 days. Bridge decks, a lot of reinforcing, a lot of restraints, a lot of potential for cracking. You want to cure it. Give it that moisture. And bridge decks probably have high volume cement contents, abrasion resistance, so forth. Okay, curing methods. Couple of methods. Supply additional water. And here you can see the surface is being sprayed. Here you've got burlap sacking that'll absorb. He puts a sprinkler out there. And this is something you guys can do fairly easy on if you're pouring a driveway at home. And even if you don't have the mats, you can set up 2 sprinklers and continuously keep it wet. You're going to use up a little more water, the water bill will go up, but when you're investing lots of money in concrete, you got to take that into consideration. Ponding or immersion, that's the best. Okay. That's why cylinders, if you don't have a spray room, those of you that worked in the lab, those cylinders that you bring in from the field got to be immersed in water, saturated lime solution water, or they got to be put in a fog room, a moisture room. Okay. Just one minute here. Something. I have to close my door. Anyhow, okay. Spraying or fogging, you want to minimize the moisture loss during and after placing and finishing. Very important. So saturated wet coatings, wet coverings, that's the best. That's the best. You've always got them wet. You've always got moisture. Okay. You're not allowing your pavement to dry out. So essentially what's happening, you got a saturated concrete and you're supplying external water from the outside and you're stopping the evaporation. As this essential water being evaporated, you give it more. Seal in the mixing water. Okay, maybe you're not going to add water, but you're at least going to seal in, so you're using plastic sheets. It's easy to do on a pavement or a flat surface, but sometimes you get complex shapes. It's hard to do, and you can see the wind sometimes get under it and starts blowing it around. You've seen that happen on a lot of pavements, so it's not easy. But again, you want to place it, but you want to do it in such a way that it doesn't mar the finish, especially if you're looking for aesthetics. So the concrete's got to be fairly set up so you can walk on it and place these planks up there to pin it down. Okay? So you may spray it first and then cover it with poly, and you want to make sure that all your edges are sealed so the wind doesn't grab it and rip it up. And here's Fabian's job. See, this guy's doing a curb. Well, he's not doing a curb, but he's doing the edge of the pavement. Liquid membrane forming curing compounds. And this is what's usually used on flat works, highways, streets, whatever. It's an easy way. Here he's got probably a big supply, and you want to make sure that it's not discolored like here, a little bit of gray. You want to get total coverage. And if it tells you to use so many liters per square meter, check them out. It's easy enough to figure out. I'm going from here, I'm going to there, plus the curb, sorry, the edge. Easy enough to figure out surface area. You guys are well trained on that. You've got a 45-liter drum or you've got a 20-liter pail. You know exactly how far it's going to go. And if the contractor says, because it's cost, he wants to go on the least coverage, because usually there's a range. But even if you take it at average, not the heaviest coating, obviously not the lightest, but in the middle. So whatever number of liters per meter you're going, or square meters per liter, whatever, it's easy to figure out. And you physically see he's got a Chapin sprayer. If you can put 20 liters in it, and he goes from point A to point B, he should be empty. If he's not empty, he doesn't have the right coverage. And check his container. You tell him to open it up. That's your job. Okay? Don't ever let the contractor tell you can't do something. He did the job. You guys are contract administrators or contract coordinators. You have the right to ensure that you have the proper coverage. At MI, when they use those big 45-gallon drums, and they've got a curing machine that actually sprays with spray bars across the pavement, it's part of the finishing training. Highways inspector would lay out those drums at certain intervals. And what that meant was that when the 45-liter drum was dumped into the machine, okay, the curing spray machine, and you travel to the next drum, his reservoir in the machine better be empty. If it wasn't empty, he didn't get the proper coverage. Then he'd put in the other 45-gallon drum of material, of curing compound, and he'd travel and spray continuously behind a paving train, okay? This is the last thing he's now spraying. And there'd be spray nozzles that would be positioned such that as he's traveling down, the edge of that pavement, the edge that you see this guy paving here, spray bars from the machine would be covering that. Got to the next interval where that 45-gallon drum was placed on the side of the grade, his machine better be empty. If it's not, maybe his spray nozzle got plugged. That's another thing you gotta do. You always gotta check the spray nozzles. Check on his if it's dripping or not, even from a handheld. If the wind is moving it all over the place, get on the other side, cover it. Apply adequate uniform coverage over the entire surface and edges for extended curing. Got to do it. And it's the same thing as you're sealing the curing membrane. It becomes plasticized almost like a plastic sheet. But eventually it'll just wear off with traffic. But you're stopping the evaporation of water. Now this is saturated. Here's partly because you're still going to get some until such time as they can place it on. And that's why it's very important that as soon as you get your final finishing, and that's usually the tining, okay? You're going to broom it or you're going to tine it for traction. That's another aspect when it comes to finishing concrete. If you looked at that unit that we didn't cover, you want to broom the surface for slip resistance. Highways usually will have like wire rake. They tine it. It's called tines instead of a broom. You might broom your driveway or your sidewalk with a stiff broom, but highways usually tines, a little different. Okay? So membrane curing compound. And the precast live steam heating coils, electrically heated forms or pads. Okay? So live steam is what's usually used in the precast plant. Okay? They'll put a hoarding over their structure and they'll pipe in steam. It's hot, it's wet. We used to, when I was at Conforce, which is now Armtech, I believe. They might have even pulled out of here now. Anyhow, we just had heating coils that were inside the formwork, inside, I should say, the hoarding on both sides of the formwork. And live steam was going through them, but the heat would dissipate. So in other words, we created heat with steam, but the steam wasn't wet. Steam was running through our heating coils to drive up the heat. And we would drive that heat up. But again, you got to be careful. You don't bust the concrete. We're going to look at that right away because you want to make sure you have a certain amount of strength before you sock the heat to it to destroy it. So there's an initial curing period before the steam comes on. And here it is. You don't have to learn this. Yeah, I won't quiz you on it. But get a minute, you can look at it. You got outside air, and then after, see, 5 hours after placing, and that's usually when you're going to get your initial to final set, you're going to build up enough strength, then you're going to sock that heat right up. Okay? And then you're going to have a holding period where it's developing its strength, and then you're going to reduce your heat. So steam temperature in enclosed held to 60 degrees until the desired concrete strength is developed. And when we were in the precast industry, we would place a girder and they wanted to de-stress it. So I would come up with a mix that at 12 hours after casting, we would get 30 MPa, 20 MPa strength. So that when they released the pre-stressed cables, the concrete would keep it without busting up. But if you put this steam on too early, you would actually stop that strength development. So there's got to be an opportune window. So I would have to develop setting time tests for the concrete mix that I developed. And then state to the floor people, you cannot turn on the steam till 5 hours after. So that means they're night watchmen at the plant. Okay. Stationary engineer would know that, okay, at 10 o'clock tonight, I can crank up the heat, not until. Okay. After a couple of years, when the brooming or tining wears off on the highway, what do they do with the surface? Well, they can grind it. They can grind it. The tining, if done properly, does wear off, but it shouldn't take a couple of years. It should be longer than that. But you can always grind the surface again. You can make it like a corduroy. We're grinding our pavements now for flatness. Okay? You'll place a slip-form paver, and you'll have a smoothness check on it. Okay, you'll use a profilograph, and if they don't have the smoothness, then they go through. Maple Leaf brings out their grinders, and they'll grind that pavement. Then you've seen that at Centerport, you've seen it on Highway 75, you've seen that on Highway number 1, even Bishop Grandin. you're taking off the high spots. So if it gets too polished, in other words, it wears off, you can always roughen the surface up by grooving it. That's why it's important, if we go back to our basics, you want aggregates that are hard and durable and won't wear. Because typically when you wear that surface off and your aggregates are weak, they're going to deteriorate that much further. Okay, so this is this is for high early cement, high early strength gain. Okay, just to kind of show you how the precast relies on moisture and temperature and high temperature, because they need it up front. They don't care about the 28-day strength. You know, if they're getting their 28 design strength at 3 days, they've got it. So it didn't reach 40. Okay. Strength versus steam curing, again, just something I'm not going to get into too much. Strength versus curing temperature. And here, this is interesting. This is what I'm saying. At 1 day, if you're curing 50 degrees Celsius, okay, so you've got, say, 16, 18 MPa, maybe 15, whatever. But at 28 days, the strength drops if the curing temperature is too great. And this is what the precast needs. They don't really worry too much about here. They want their initial. So here's a good graph. Okay, 10 degrees, you're going to get good strength at 28 days. But the initial temperature drives your early ages up, but it starts to decrease at 28 day if your temperatures are too high. And that's why in the field, of any of you guys that have tested concrete, you need initial curing temperatures between 15 and 25 degrees for your test cylinders for your initial 24 hours when you set them up in the field, and you go back the next day to pick them up. Then you're going to put them in a moisture environment in the lab at 23 degrees plus or minus 2. Sorry, 23 plus or minus 2. Okay, so 1 day strength increases with increasing curing temperature, but 28-day strength decreases with curing temperature. Okay, so it's kind of a reverse curve. So if you need early strength, temperature above your typical curing temperature is going to help you, but it'll decrease your potential for 28-day. Any questions so far? That's a good graph. That's a good graph, guys. It's a good graph. Read it, understand it. And then there's also penetrating sealers, where you can use either silanes or siloxanes. Okay, these are sealers that are basically more water repellents. Okay, you wax your car and it rains, and you'll see how the water just kind of beads off your windshield or off the body of the car because you got a nice coating of wax on. Penetrating sealers will penetrate the surface, but not very deep, and is more of a water repellent, but it will prevent water from intrusion into your mix, into your concrete. So a penetrating sealer will also help to seal some of that moisture in so it doesn't come out. And this will be typically used a lot of times for concrete, more as a maintenance later on, because we know that there's still moisture in the mix that may have not hydrated. So let's add a penetrating sealer to keep it in there if we can. And this is you can see this is a hardened surface. They're penetrating through the existing pore structure. And there's different types. There's silanes, there's siloxanes. Like just getting into a little bit more about chemistry on the sealers. And that's basically it for curing. But so this is, I just can't stress, it doesn't look like there's a lot of information, but it's key. It's key. And if you're ever out there, don't take it lightly. You know, like I said, we spend so much time on testing concrete when it comes for the before the fact or during placement. But the most important part, to preserve your investment, the money that you spent on getting that pavement down, to just have your concrete deteriorate prematurely because of something like curing not being followed. Any money now is gone out the door. You sure didn't get a bang for your buck. And, you know, contractors are going to try and tell you everything. And sometimes the worker may not understand, the guy placing it. You know, Sometimes as a young individual, he's been told, go cure the concrete. Doesn't know much about it. So when you talk to the foreman or the contractor's contact on site, you got to explain to him, you want that pavement covered with curing compound. You don't want to see gray. You want to be able to check his coverage rates. And like I said, that's very easy to do. I mean, even, your control joint spacing. It's easy to know. That's the width, that's the length between joints. This is my surface area. And the start of any job, he should have, if you know that he's anticipating, you're anticipating a certain length of pour, before he even starts placing in that day, talk to the contractor. Do you have enough curing compound on site? Because this is how much you're going to need. And if he needs, say, 5 20-liter pails and you only see 1 20-liter pail, then you better mention to him to get some more, or don't let him place. Don't let him place the concrete. That's your prerogative. You got to look after your owner's. You're the owner's representative. You got to look after the owner's requirements. That's what he's paying you for. Unfortunately, sometimes your superior may override you. That's a problem within the company. Then there's not much you may be able to do about it. But you gotta at least take due diligence to make sure that things are done right. Okay, so that's it. Anything else? This is curing. Any other questions? No? Well, okay. Your last lab is due today. There's no lab I'm giving today now. So next week, we're going to have these units. And again, the same thing, we'll have the afternoon session for getting into asphalt. I'll finalize a block schedule, make sure it's up to date with the the asphalt. Okay. No other questions? Boy, you guys are all there, or everybody sleeping? I'll stop sharing this. Okay. If there's nothing else, oh, it went smooth, all good. Okay, thanks.
Hey, John,
Yes, Kelly.
how many labs in total are we doing? Do you know?
We've done 5 for asphalt. There might be. We're not gonna test the asphalt cement because, I mean, that it's not done that much in industry. We usually do when we have face-to-face, but I'm not gonna do an online one. There's gonna be 4, maybe 5. 5 might be, the 5th one might be more of a write-up of your result. So like a paper. Well, they're all paper labs, I guess now.
Okay, so there's about 4 to 5 left.
Yeah.
Okay,
Yeah.
thank you.
Okay, anything else? Yeah, if some of you have questions, you can wait till the end, and I'll keep it open, and then we can discuss if you have any questions you want to discuss after this. If not, then have a good day, have a good week. If there's anything you need, let me know. Okay, thanks, guys. Okay, thank you. I'll check. Yeah, I always check my email, so I'll stop the recording here now. Yeah, everybody have a good weekend, guys. And a good week.
Hey, John.
Yes, sir.
For the lab, for the write-up, can we do it in table form to put all the info that it's asking? Or is it, because it's already in a table from the data sheets, but we were just finding for like, because it was asking for the diameter and the compressive strengths and all that. It was just easier and like neater to put it into a table.
That sheet that you use for lab 4 has a table on the back. Page 2 and 3, you've got one for compressive strength of cylinders. There's a table there that'll give you your 7-day.
Yeah.
3. Yeah, so
Yeah,
just
we
fill that
filled
out.
that out, but you wanted like an actual written report as well, right?
Oh, yeah, because what you're going to do in your written report is you want to summarize your breaks. Like in your written report, you don't have to give me diameters. As a client, I don't understand that anyways. But tell me in your written report, what is my 7-day strength and my corresponding 28-day strength?
Okay,
And you
so
don't
you
have
just
to.
put the average for those then.
Yeah, you don't say cylinder 28-day cylinders broke at 1, 2, 3 average so. You'll just say the 28-day compressive strength 35.6 MPa or whatever, 42
Okay.
MPa.
Okay, so
Then
we'll just do more.
yeah, and then you make a reference for all pertinent data and test results are attached on the following form or on the following attachment, whatever.
Okay, so
As a client, yeah.
the information that I was asking for in the ASTM there, that's more for what you need on the data sheets as well, right?
Well, the report has to have a certain minimum to CSA, right? Some of that you're going to tell me in a letter, but some of it is already on the data forms.
Okay.
Okay, so you provided me that information, be it
Yeah.
in the data form or be it verbally in a paragraph in the letter report.
Okay. Thank you.
Okay. Clear as mud?
Yep.
Okay. Anybody got anything else? No? Yes, maybe. Well, okay. That was my question. Okay. Yeah. I'll keep my WebEx open a bit, so for those of you that want to talk after, that's fine. Or we can do my email. Okay. Do you have a question, Leanne or Emmanuel? Pavel? You can send me an email or we can set up a WebEx later if you'd like, or Emmanuel, how are you doing? Is there anything I can help you with? Anyhow, okay. I'll shut her down. And again, if you want to talk with me, send me an email. We can always do a WebEx. Okay, good enough.